workshops with some primary teachers, and we went into schools to observe existing computing and maths lessons just to see what's happening at the moment. And we used all of this information to come up with a high-level overview of what the intervention could look like, and also some initial draft activities. We then took these activities and working with our 4 design schools, so we have 4 schools in London that we've been working with very closely throughout the project, and we took these activities into the schools. We observed what happened in the class, how the teacher taught the activities, and we talked to pupils and teachers during this process. And each time we did this, we reflected on what happened and refined the activities further. So every single activity currently within the first year of intervention has been tested once or more in a variety of different schools. So we're sure, this makes us sure that these activities can work successfully in the typical primary classroom. Another element of the intervention is our professional development programme, and this is also something that has been designed through this process. So before the first set of teachers started teaching, we undertook 2 days of professional development with them, and during this time we talked to the teachers about what their support needs would be, and we also undertook pre and post surveys before and after these 2 days, and this gave us an idea of how we could actually create a suitable professional development programme to go alongside our curriculum materials. And the phase that we're currently in at the moment is with these treatment schools that are undertaking the first year of intervention. So we have today gone into a subset of these schools to observe the same activity from our intervention, to see how different teachers implement the same activity within their different classrooms. And we also interviewed teachers and a range of different pupils after the lesson to find out what they learned from the lesson, how they overcame challenges, and how the teachers adapted our materials and resources in order to make them more appropriate for their class. One of the outcomes of the first phase of our design research was this 5E pedagogical framework that Ivan mentioned this morning. And this framework was derived from constructionist principles, also previous research that's been undertaken in this area, knowledge that our team already had, and evidence of good practice in primary mathematics. And to give you a bit more detail about what these 5E's are, the first E is explore. So it's important that we had activities that gave pupils the opportunity to investigate things, try things out for themselves, that they had the chance to envisage or predict outcomes of programs before they actually tried it within the tool, that they were able to explain what they had done and share with others why they had done these things, that there was opportunity for collaboration, so this enabled them to see something from someone else's perspective, also compare what they had done with another child, and lastly, bridge, so to make explicit links with the mathematics curriculum, but also other curriculum links as well that we've identified. So we wouldn't necessarily have an activity that just on one of these E's, but one activity could encompass one or more of these different elements of the framework. So now, just to give you some examples of what we mean by each of these constructs, I'll go through a few of the design principles that we've used that have guided the development of our material. So, in terms of explore, one of the things that we wanted to do within our activity was to move firstly from direct control, so clicking on a block and observing the reaction, clicking on a block and observing the reaction, to actually planning a series of behaviours like snapping the blocks together and then clicking them as a script or a programme. We also didn't just want to introduce a concept for the sake of it. So in some of the existing courses that we've seen, they try to introduce everything that Scratch would do, which is a lot. And so we wanted to focus on the things that people really needed to keep. So in this example, in creating a repeating pattern, rather than having to click on a script multiple times, this then introduced the need of having a repeat block, which meant they could only needed to click on it once. One of the key parts of our intervention is a series of unplugged activities. So this enables pupils to predict the outcome of their scripts before they actually try it in Scratch. So this activity was about simplification, so they had to identify the two scripts that produce the same outcome and then match them up. And we also wanted to incorporate this idea of synchronicity. So we wanted to encourage both teachers and pupils to identify with the script that they're programming with and actually step through the script in that way. All of our activities highlight the key vocabulary that we're introducing. So this provides pupils with the language in order to explain what they've been learning, and to provide a series of debugging strategies or different approaches to solving the same task, so they can recognise that there wasn't just one answer to a particular activity, that even something as simple as drawing a square had multiple different approaches that they could take. In terms of exchange, we wanted to provide a need to share their ideas with others and build on each other's script, and also include collaborative activities. So this could be pair work where children of similar abilities work together, or also where they, a child that was more able to help the people that were struggling, so they provided some tutoring and support to them during the activity. And lastly, for Bridge, we were keen that we align the progression of the computing and maths concept to the national curriculum, and also that we included mathematics focused discussion questions for the teachers, so it was very clear to them how they could link to the pupils' mathematical knowledge. Okay, and some preliminary findings from the work that we've done in schools today. One thing that we found during the design process was that totally open exploratory activities didn't work very well, particularly really early on in the modules when we were introducing new concepts. So an example of this is we wanted to introduce Benton, and first of all we had quite an open activity where we said to people, try using at least 2 colours, at least 2 pen sizes, 8 lines, and this activity wasn't very successful. People were confused, teachers were confused about what they had to do, they were trying to recreate examples, and really we wanted all sorts of different outcomes. And so we adapted the activity so it provided more guidance, but still space to explore. So in this refined version of the activity, we wanted people to explore the potential to create different Roman numerals, which actually links to an element of the mathematics national curriculum in England as well. So really we found that early on in the modules we needed a goal for the pupils and teachers to work on. We also saw that within some of the classes where more pupils achieved the learning objective, we found that teachers here were using multiple representations simultaneously of a script to help scaffold the process of learning. So, hopefully this will work. In this particular activity, we're introducing 2 different algorithms for stamping patterns. So some of the teachers would step through, or they'd have pupils stepping through this script, and also having the video playing at the same time, which is something we created to support the understanding. And this really helped identify any errors that the pupils might make and make it clear exactly what is happening in this script. We found that it was important to give opportunity to explore ideas before we then define them. So this happens within both the professional development with the teachers and also with the pupils. So this helps give something concrete to talk about after they've done the more exploratory activity. And we observed that the teachers implemented scaffolding for pupils who are struggling in lots of different ways, using the resources we provided them and adapting them in ways that we hadn't necessarily suggested. So again, in this pattern stamping activity, some of the teachers use unplugged worksheets as a support for the work that the pupils are doing in Scratch. So the example on the left, we've got some scripts that are correct, some that are incorrect, and rather than starting from nothing, pupils could rebuild these scripts from scratch and then experiment with which ones could create the pattern that they were trying to create within the activity. We also had teachers providing scripts about any values, so the pupils could change the values in this and again experiment with what worked and what didn't and try to understand why that was. And teachers commonly got pupils that successfully created patterns and shared them at the front, and this helped other pupils get ideas from their peers that they could then try in their own project. The unplugged activities that we incorporated seemed to help pupils be able to consolidate their learning. It encouraged them to explain to themselves by reflecting on what they've done, and it also enabled them to link to mathematics. But we found that in some of the activities we initially had some unplugged alongside some work in Scratch, but we found that people were just too tempted to try things from scratch. They didn't want to spend the time predicting. So it was important that the unplugged activities were entirely away from the computer first, so they had some time to reflect before they then went back onto the computer to try things. And lastly, we really needed to be aware of the tensions and affordances of the tool, particularly when it's linked to the maths curriculum. So within our pattern stamping activity, some of the teachers said that the topic of angles could be very tangible for pupils, and it really provided a concrete way of explaining this topic. But Scratch does allow you to put in enormous numbers in repeat and create still create a complete set of patterns. So it was how the teachers handled this, because all pupils would initially try to do something like the bottom on there. And in terms of using the coordinates grid, within year 5, they only looked at one quadrant of the grid. And so this is quite a nice way of introducing all 4 quadrants, but other teachers felt that the pupils needed the underpinning mathematics knowledge in order to then do the activities in Scratch that we provided for them. Okay, so in terms of the next steps, we're currently continuing with our qualitative evaluation of selected lessons, and so far we've seen some considerable variation. Some of the things that we're looking at are how the teachers take on board our design principles and how they adapt to the scaffolding that's available, and we're hoping this can help us understand links to the learning outcomes that we found. And we're also looking at ways that we can provide ongoing support for the teachers during this 2-year intervention as well. And we are currently refining our D6 curriculum, which will be teaching this September in our treatment course. So this is the team, and thanks to the funders at the Education Endowment Foundation. If you want more information, the details are up there. Thank you very much for listening.
Laura, so we have some of our evening's questions. So,
Thank you, Laura. in your RPs, you see some activities, but also there's a lot of things that the students have to talk about. How's the dynamic of the classroom? What's the teacher is doing? And the second question is, you can give an example of what the unplugged activity is.
Sorry, could you just explain the first part again?
The first question is the 5 E's.
Yeah.
We have things the students are doing, but also they have to articulate a lot of ideas, explaining things, how is the dynamic of the school, the classroom, what's the teacher doing?
Oh, so the 5 E's are supposed to be guiding the teacher, so it's the pedagogical framework, so the way the teaching approach to facilitating the activity. So I guess it could potentially be changing the way that the teacher would normally deliver their lesson. We focus quite a lot on it in our professional development with the teachers, and we've been providing ongoing professional development sessions during the intervention as well. So we've really focused on pedagogy in our follow-up professional development sessions once the teachers have had the opportunity to try some of our activities with their pupils. And we provided examples of things that we've seen and ways that within our approach we would suggest dealing with it, and the teachers also shared things that they had done. So I think it wasn't until the teachers had the opportunity to try things for themselves that they really got what we were trying to talk about and the way we were suggesting to teach it. But we actually had some teachers really incorporating the language into how they were describing what they'd done in the classroom. But I think certainly is a change for some teachers. And okay, the second question was about the unplugged activities. So one of the examples there, so it would be a worksheet-based activity that was related to some of the work that the pupils had done in Scratch. So the example that I gave before, we wanted pupils to understand, so early on in the modules, they would feel very long scripts just because they thought that was having more blocks meant more work. But actually, they didn't need all of those blocks, they could simplify their scripts. So we provided them with some examples of some longer scripts and shorter scripts that did the same thing. And then their activity would be to match the more complex script with the simple script. And they would do that entirely away from the computer on a worksheet.
That we are not running a randomized control trial. Independent evaluators from a different university who, in a sense, was imposed upon us as a condition of getting the grant. So that's number 1 point. Number 2 point, so there's no sense in which what we're trying to do is teach somebody about computing so that they will automatically know more about maths at the end. If that was the objective, then that would be a pretty fatal objective, I think. What we're trying to do is much more difficult than that. We're trying to say, if you spend a year learning computational concepts, learning to speak the language of computational concepts, then is it easier for the teacher to teach those ideas translated into a mathematical framework? So it just isn't true, by the way, that there's no conditionals in the maths syllabus. It's just they're not called conditionals. But people want to know things like if x is greater than 5, what does this line look like? That kind of thing. So this is a complex problem. The third thing I just wanted to say, which is kind of a warning for next year, we don't get to choose what the maths test looks like. Life would be a lot easier for us if we could say, here are these 15 concepts which we know are going to be tested in the maths curriculum, and they map beautifully onto 15 concepts of computational science. Unfortunately, that's not the case. And some, I have to say now, some of the maths test questions that the kids will do are completely fatuous. And our first job when we analysed the data was to chuck those items dustbin and focus on the life that's something to tell us.
Thank you. So, is there any other question? I think the last one.
I'm just wondering, as you said, you're not covering all aspects of maths. How much of the maths curriculum and maths teaching time is being devoted to ScratchMaths? And do you have anything for what teachers are doing? Whatever's underneath?
No, so it's really left very open to the teachers in how they choose to, in which part of the curriculum they can actually choose to teach the ScratchMaths lessons. So we're actually collecting data from the teachers in how what decision they've made. So this year, some of them are teaching it as a computer lesson, some of them are teaching it within maths, some of them have called it ScratchMaths and it's a separate lesson. Some of the teachers have changed their maths teaching to map to what they're teaching in the ScratchMaths lesson. So, for instance, they're teaching angles alongside the first module where they need this knowledge, and they're actually bringing in sometimes scripts from scratch to help children make the link there. Next year, the links with the maths curriculum are a lot more clear. For instance, one of the modules is called focused around place value. So it may be there that the teachers change and actually use a maths lesson to teach the content, but it's entirely up to each school, individual school, and how they introduce it within that already very busy time.